Okay, hi guys, this is Mr. Coumbe. Let's look at the next part of our actual research. So let's go back to those research example questions. Do sports drinks affect how students think? And does personality influence happiness? Now, let's have a look at what kinds of research these are coming from the other one. What kinds of research are these two and why are they? So the first one, do sports drinks affect how students think? If you think about it, it's actually you can easily do experimental research with this one. Why? Because we can change, manipulate the variable, being the sports drinks, and how look at exactly how by manipulating the sports drinks themselves, how that causes an effect on the cognitive ability of students. Where personality influencing happiness, that's definitely not experimental. It's going to be very, very hard to measure directly, and it's going to be very hard to measure it objectively. So personality, what is personality and what is happiness? And there are a lot of variables that are really going to be very hard to control. They're going to have big influences on the outcome. So we can't actually establish a cause and effect relationship, but we can establish a correlational effect on this particular experiment. That's why we call it non-experimental. All right, we do research, but we've got these questions. Now let's decide on who do we actually measure it on. And this is where we're talking about population and sample. Now, population, pretty straightforward. It's that group of people that it's the whole group that will share some sort of similar characteristics, something common between them. Now, that common characteristic, a lot of the times, the reason why we would actually research this massive group of people is because that particular characteristic might have something interesting for researchers. Now, because generally speaking, populations are massive. So if you just talk about people in general, if we wanted to measure people, it would be ridiculously hard, near impossible to measure every single person on one particular characteristic. It would be ridiculously expensive, it would be ridiculously time consuming. So in order to do that, we take what's called a sample. Now we might do a couple of different ways to actually get a particular sample from that massive group of people that share particular characteristics. We take what's called a sample. Now a sample is just, so if we have a look at this group of people here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then if we take a proportion of that population of 12 people, so we take a quarter, so this is a subset of that 12, to try, and we, instead of measuring all 12, we'll measure these 4 instead, and then the assumption would be that these 4 would be representative enough of that population in order for us to get good data, because we're using a quarter of the population to represent the whole population. Now, let's have a look in terms of how we might think of the population. Pause this video. What do you think is the population of these two questions? All right, ready to unpause? All right, the population in the first one obviously is students because it comes directly in the question itself. Do sports drinks affect how students think? Now, the population, now students is a really, really vague demographic, right? There could be billions of students on Earth right now. And because this one doesn't actually specify who they are, so then we go to the absolute biggest demographic, which is people in general. Now, to get a sample from these two, how are we going to do it? There's a couple of different ways for us to get a sample. Now, like I was saying, students themselves can be massive, and people actually just means everyone. So it's hard for us to measure all students and everyone. So we need to take a subset of those two populations. So we have a bit of a problem here. How do we actually do that? That seems like a pretty big job. So there are some methods for us to actually get onto that. So here is some ways that we might actually get a subset. So let's say that in that first experiment, we had researchers at a particular university in the psychology department. Then they advertise it to their students that just have to participate in the study, and then give them incentive to say, all right, if you participate in my study, you're going to get extra credit at the end of the semester. And so because of that, this psychology, let's say hypothetically, they actually then got 200 volunteers from that. They were aged between 18 and 36, and there was 140 females and 60 males within that 200 volunteers. Now, generally, when we talk about samples, some things that are important when knowing about samples. Well, how many? So how many samples there are, right? What population we're representing. Generally, we want to talk about their gender age. So not gender age, their range of age. Sorry, their age range. So in here we have 18 and 36 is the age range. And we also want to have a look at the gender proportions. Now this becomes very, very important later on, which I will tell you guys exactly why. Now the second research, let's say some researchers went to like a whole bunch of busy shopping precincts so that we try to get as many different types of demographics as possible. And they went and asked the shoppers that went by to have a questionnaire that measures their personality and that measures their happiness. Now from this they got 2,000 volunteers, which is awesome. They might have done it for a while. Now they got the age, so volunteers, people, they got them from 16 to 64, and there's your gender proportion. Now, are these samples that we've gotten, are they good representations of the general population of students or the general population of people? Well, not necessarily, because depending on how you do it, you're going to introduce something called a sample bias. Now, a sample bias is a systematic error, i.e. an error from the methodology itself that you introduce by the way you sample and the way you take that subset from the general population. Now, it's going to be biased if that subset is not representative of the population, i.e. if some demographics are overrepresented or other demographics are underrepresented from reflecting from the general population itself. So we can also get sample bias if the actual sample itself is either too small or not large enough, right? Because if you get 7 billion people and measure 10 people, those 10 people are not going to be a good representation of 7 billion people. And once again, if the proportions of the demographics of the population are not represented, then it cannot be, then the sample is biased. Now, why is it important? Because we want to try to draw conclusions and draw generalizations that we can actually apply to the wider population. Now, if these things are not met, then we simply cannot give a generalization or a conclusion to the wider public and say, a really big one is, say, boys are always aggressive. That is an enormous generalization. If we did an experiment where we went to a very low socioeconomic school and we measured the year 11 trades boys that were on the pointy end, and we measured like only 10 of them, and these are like the kids that potentially could be the worst kids in the school, then of course it's going to be huge bias because those kids are going to have a higher probability of being aggressive. And so our data will show that boys are aggressive. So that's introducing that bias into that sample. Right, here's where it's going to get exciting. There are 3 ways that we can actually sample. All right, convenient sampling, random sampling, and stratified sampling. Each of them have their pros and cons. This is where it's going to get exciting. First, let's talk about convenient sampling. Now, in terms of research, a lot of the times researchers don't have that many resources, and sampling people, being i.e. going to different places and around the world to in order to give everyone some like an equal share in being able to be part of the research, sometimes it's impossible. So sometimes we can use the population that are, or the sort of subset of people that are most closest to us. The big advantage of this is it's really quick and it's convenient. However, you're going to introduce big times, a lot of the times, a bias within your sample itself, because there are demographics of the population that are simply not going to be represented. So here's an example. So let's say Master Yoda, he wanted to measure the strongest, so the strength of the Force in different kinds of Jedi. So he wanted to have a look at the and he wanted like the strongest Jedis for his team to fight the Sith. So if this were, so here's our population, we have all these Jedis to choose from, and then Master Yoda was like, all right, I'm going to take a convenience sample. So his convenience sample would be literally those Jedi that are closest to him. So he'll sample those Jedi literally closest to him, and he'll say, all right, I'm going to measure for you guys to see who is the strongest kinds of Jedi. Now, there's going to be a big problem with this if you have a look. So in our population, we have Jedis with blue lightsabers, green lightsabers, red lightsabers, and purple lightsabers. But if you look at our sample here, we can clearly see that the red, so of the 5, we have 2 reds, 1 blue, 1 green. The red, 3 reds, apologies, 3 reds. 3 reds, 1 blue, 1 green. So we can see clearly the red lightsabers have been overrepresented, and both the green and the blue have been underrepresented because they don't represent the proportion that's available that it was in the actual population, which I can tell you already is 25%. And the purple lightsabers have not been represented at all. So there's a massive bias if Master Yoda were to base his conclusions simply on these proportions. Now, there's another way where we random sample. Now, most research is based on random sampling. And in this one, ideally, we give every single member of a particular population an equal chance of being selected. Now, realistically, obviously, that's really hard to do. It reduces the bias significantly because, on average, these differences should even out within a population. But the problem is, in reality, there still might not be a full representative because of chance itself. All right, there's no because chance can still mean that there's still bias within the sample itself. How do we random sample? We can pull the names out of a container pretty simply, or we can give a number to every person, and then after we do that, we generate some numbers from a random generator and then select the sample from there. So let me show you the second method with random sampling. So back to our population, Master Jedi Yoda wants to measure and wants to find out who are the strongest Force users. So what he might do now, he might give a number to all the population of Jedi that he has available for him, and then he creates a random number generator. Alright, so from that random number generator, there we go. So he randomly chooses those Jedi. And so here they come. Here comes those Jedi. So number 19, 21, 2, 4, and 10. So even though he gave every single person an equal opportunity to actually represent and be chosen in the sample, because of chance, we still have under and over representation. So here, obviously, the red lightsaber Jedis have been massively overrepresented. The blue have not been represented at all, and the purple and the green have been underrepresented. So we're going to introduce massive biases there. What if the blue lightsaber ones actually were the strongest, and the purple ones were actually the strongest, but on average, if you were to average out the red lightsabers, on average they're slightly stronger than the purple one, but that number 2 purple just happened to be the strongest of everyone here. But on average, the purple ones were actually pretty weak. He just happens to be the strongest one. So it's going to be very biased in the sample. Right. The ideal one that reduces that bias, allowing the population to be representative, the sample to be representative of the population, is stratified sampling. This one, unfortunately, is very time consuming, and a bit of information is asked of the individuals before they can actually be selected. Okay, so you break them down, you break the population into groups of shared characteristics, then you randomly select from each of those categoric groups that you actually produce, so that the whole population is represented in the sample itself. So let's look at that example before. So we have all this data. So a characteristic that they're going to share to find out the relative proportions in the population. Let's sort them out into their lightsaber colors. So here we go. So they've been sorted out into lightsaber colors. So Master Yoda says, all right, let's sort you out in lightsaber colors. And we find out that it actually ends up being 6 in every single category, with there being 4 types of lightsaber users. So, and they're all even exactly. So each lightsaber color represents exactly 25% of the population. So our sample needs to reflect this. Then what you do, you give numbers to each of the members of those categories, and from those categories you randomly select according to the proportion. So here, because it's only 25% of the population, i.e. a quarter, I would be able to make a representative sample if I were to take one of each, simple as that. So then we randomly generate and randomly choose one from each of the categories. So red 2, purple 3, blue 5, and green 4. And then they come along. Here we are. And so now we have a representative sample. Now this is much less likely going to be biased, because those proportions of those in this particular sense, the proportion that we most want, because we're trying to measure the ability in the force, then every single demographic is represented in their correct proportion. Now if the proportions were different, then that would be a different story once again. And yes, so that concludes our sampling methods. Next, we're going to go into how we actually design an experiment itself. This is Mr. Coumbe. We'll talk to you guys later.